Bedekat and I have sat down and we said, okay, how do we now come up with a technology system that can deliver the greatest amount of service to the customer within their window of affordability? We decided to distribute the infrastructure of the system out into clusters of houses and to separate a central power station, which is this, and the distributed power stations for the houses as these little boxes. And by using that trick, we now are able to build a distribution system with very thin wires that are cheap enough to make the distribution system affordable to everybody. In this particular design of the microgrid, we start with a central power station. The central power station has a connection to, in this case, approximately 200 watts of solar panels up on the roof. And the power from those 200 watts of solar panels comes in to a charge controller. That charge controller stores the electricity in a large lead-acid battery. This particular deep cycle lead-acid battery has about 100 amp hours of charge storage. And then that battery sends the electricity to 4 groups of households through a DC to DC converter. So now let's follow the electricity from where it's pushed from the DC to DC converter to the distributed power stations that manage the electricity for the individual groups of houses. So the electricity from the converter goes through, in this case, 250 feet of wire. This is thin gauge, 18 gauge wire, fairly thin. But what it does is it sends a constant trickle of electricity to the houses. And then over at the houses, each group of houses has its own portable power station that manages the flow of electricity to the household group. This particular portable power station is designed to manage and deliver the electricity to a group of 4 or 5 houses. The way it does that is it takes multiple sources of electricity. It brings in electricity from the central grid that you just saw back there. It also has a source of electricity from its local panel, which is only 50 watts rather than 200 watts. And it manages the electricity through the electronics and the local batteries. Because these batteries are being used every day for the daily demand of the households, rather than using the lead acid batteries, which don't last so long, we're using high quality lithium iron phosphate batteries. The nice thing about the lithium iron phosphate batteries is that they can last more than 2,000 cycles. Because the lithium iron phosphate batteries can last 2,000 cycles, that means we have the possibility of having a system that can last 5 to 10 years rather than developing problems within the first 2 to 3 years. The portable power station takes any excess electricity, and this is part of the social purpose of our organization. It takes some of the excess electricity that comes out of the solar panel, and it runs some portable fans. What we plan on doing with the portable fans is we plan on putting these fans into people's kitchens so that they can help remove the smoke that people generate when they cook their food over wood fires. Indoor air pollution and smoke from wood fires kills more than 1 million people in the developing world every year. So let's first go over the sources of electricity coming into this power station. The 2 key sources is a trickle charge coming from the central power station. And the central power station is sending a little bit of electricity 24 hours a day into this household group. That electricity comes in through the side here and is run through a current controller that makes sure that the charge flows into the batteries without any of the charge in the batteries flowing back out to the distribution system. In addition to the distribution line, we also have a solar panel power line. That solar panel power line comes in here, and it goes into this voltage current controller board, which sends some of the electricity of the solar panel down to the batteries, and it pulls off a little bit of excess electricity from the solar electricity, and it creates a 5-volt power supply that is used for some extra electricity uses. The nice thing about a 5-volt power supply is 5 volts is the voltage that comes from that you use from a USB outlet. And that 5 volts can be used for running USB appliances. Any low power USB appliance, whether it's a fan or a radio, it can also be used for charging your phone. So now the key thing is that the distribution system and the panel both feed in to the battery input. The battery input goes in here and it charges a lithium iron phosphate battery pack. That is the workhorse. The electricity output of the batteries then goes into the input of the micrometer. The micrometer is controlled using text codes, just like when you top up your cell phone. So you pay to the village shop. The village shop gives you the codes for your meter, and then you enter the codes of your meter into the meter to top up the account of your meter to keep the electricity flowing. The electricity then flows out of the meter, and it goes to 2 separate places. One place is it goes through this display to both display the voltage in the system, and this display also converts electricity to a 5-volt supply that can be used for a nighttime USB loads. The other part of the supply goes out and it powers a series of houses. So the main cord in this case is connecting up to the distribution cords that go, in this case, to 5 houses with 2 bright light bulbs each. We basically set up a mock-up. We have 4 distributed power stations. We have a central power station. We bought all of the parts that we thought would be required for a system, and it came out to $3,500 for the equipment necessary to provide electricity to 20 households. You know, remember, 20 households paying $10 a month, that's $200 a month. $200 a month times 12 months is $2,400 annual revenue for an equipment cost of $3,500. The way we plan on negotiating the deal is that 50% of the revenue goes to paying off equipment. And what we're going to do with the revenue that goes to paying off equipment is we're going to try to expand to as many villages as possible. Okay? The other 50% of the revenue retains with the local partner. Okay? How that 50% of revenue gets negotiated amongst all the stakeholders is a question we're going to leave open and basically leave as a responsibility to the local partner. We've made it very clear that we expect them to take care of all of the local issues with their 50%. And they realize that in terms of dealing with, you know, we're a social benefit corporation, right? From a typical pure for-profit corporation, they will never walk in and give a straight 50-50 revenue split to a partner in Africa. Or that is very, very rare because they know they can always negotiate a smaller margin. Most of the initial physical equipment, right? Things that come in as most of the initial investment cost, we'll take responsibility for, including the light bulbs. We will probably provide a replacement stock and some version of a warranty to give us an incentive to provide high quality, long lasting equipment. Because these light bulbs, if they are high quality, should last a decade or more. These batteries, if they're high quality, should last more than 5 years, right? We should be able to get most, if not all, the equipment to have a 5, 10, 15-year lifespan. Centrally, it's totally scalable by just replicating. And we can put basically a 15-volt supply bus that you're with a thicker wire that's running multiple household cluster distribution lines off it. So the basic geometry by being so replicable and parallel allows the customer number to increase pretty good. And then the other way of increasing the scale is to replicate the distributed power boxes and put fewer customers per power box. So that allows the electricity services per customer to increase in a very scalable way. The US side of the US partner is responsible for the technology, the design, the technical support, and the supply of the high quality, more recent technology parts that are necessary to have the system operate at maximum efficiency on the ground in Africa. Okay. A huge factor in commercial viability is your cost of going from bringing the equipment into the country to deploying it on the ground in a village. And if what you have to do is build all that organization yourself, starting from being an organization in the US where your labor costs are 100 times market labor costs in Malawi, then you are going to have a really, really hard time not putting in a 5x markup to recover all your costs from entry into country to deployment in the village. And so the key thing we're doing to address that issue is to increase the revenue share of the local partner, but to leave the major responsibility of the in-country organization and infrastructure to the local partner, and to work with the local partner who has an established distribution system and network of services that can be leveraged to get the services into the communities of interest. So the fact that we're providing them access to that technical knowledge makes it so that they are eager and willing partners, because everybody else is going to want them to pay now for access to that knowledge. What we're saying is, look, develop a relationship, develop a partnership. Then when we develop this long-term commitment to have a partnership, your access to the knowledge is free, right? Because it's building the partnership, because we're dividing this partnership 50-50. So the huge thing that is going to do is we get a loyal customer base that's paying us $10 a month. And every incremental expansion, our cost of providing the same service drops between 10 to 40% per year. Then that turns us into an innovation business that then basically is making money off of expansion, because we're able to provide better service at lower cost. And the beautiful thing about that model for electrification in Africa is, where the company is 10 years from now depends mostly on how fast it can get to the 100 million customers, right? It doesn't depend so much on what our profit margin is right now. It depends on how many of those 100 million customers we can provide the best service to.